Alright, so this is my lab report on Lab 9, Electric and Magnetic Field Charge Dynamics. Alright, so the main goal for this lab was to simulate how differently charged particles would behave when put in different scenarios, such as different magnetic or electric fields. The purpose for doing this was to see how the particles would move or not move when they would experience forces from the different types of fields or different starting conditions. The lab was pretty monotonous in a way, but because mainly due to the fact that we were just doing the same thing over and over again with some slight differences. But I will say those slight differences did produce some pretty significant differences in results. So yeah. For this lab, we used some code that we were provided with in a trinket window to observe the responses of these charged particles, because it'd be kind of hard to do without actually having it like in a program. The scenarios that we had did anything and everything from changing electric field directions or strengths, or magnetic field direction or strengths, and even how what charge the particle had, or what direction the charged particle was moving in, or if it was moving at all, how fast it was moving, stuff like that. So these two scenarios are both both have an electric field pointing up in the positive y direction. So on the left, it shows a positive charge starting at rest, and it is being pushed upward. And on the right, we have a negative charge starting at rest, and it is basically being pushed downward since it's going to oppose what the electric field is doing. These two scenarios are in the same electric field. On the left, the particle starts with an initial velocity in the positive x direction. So it basically starts going in the positive x direction. Since the E field is pushing it upwards, it's going to curve upwards, and it'll continue curving until it basically it'll practically be going straight up, but it would take a while for it to get there. And on the right, it is the same electric field, but the particle is starting with an initial velocity in the negative y direction. So it's going to start off going down, but since this is a positive charge, the electric field is going to push it back up. So it's going to slow down in this descent, and then it'll stop and turn around and start going back up again. These two scenarios are in a magnetic field that's going in the positive z direction. So on the left there, the particle starting at rest. Since there is no electric field, there's just a magnetic field going in the positive z direction. The particle is not going to move, it's just going to stay still. On the right there, the particle starts with an initial velocity in the x direction. So it's going to actually go clockwise. It's going to spin, it's going to rotate clockwise, and it's going to start by heading to the right, and it's going to curve down, go under, and come back around over the top, and just keep going around and around in a circle. These two scenarios have the same magnetic field as the last one. The last two scenarios. On the left here, it is a negative charge with an initial velocity in the x direction. It's going to start going to the left, and then it's going to go counterclockwise. It's going to go down, underneath, back up around, and we'll keep going like that. On the right, we have an initial velocity in the y direction. So it's going to start by going up, it'll curve over to the right, and it'll go back down, curve to the left, and then keep circling like that. these two scenarios also have the same magnetic field in the positive z direction. So on the left, we have the particle having an initial velocity in the z direction, so it's just gonna keep going straight in a straight line in the positive z. On the right side, we have an initial velocity in the x and the z, positive x and positive z. So not only is it going to move in the positive y direction, the positive z direction, it's going to move in a circular pattern, almost like a helix, and going to keep spiraling into, I'll just keep going in the z direction. Alright, now these two scenarios have an electric field pointing in the positive y direction and a magnetic field pointing in the positive z direction. On the left, we have a positive charge starting at rest, and it's going to be doing, it's basically bunny hops. It's going to go curve up, over, down, stop, up, over, down, stop, up, over, down, stop, and it'll just keep doing that forever. On the right, we have a negative charge starting at rest, and it's going to be doing the same thing, but it's going to do the inverse, so it'll go down, curve, go up, stop, down, curve, go up, stop, and it'll keep going like that as well. And these last two scenarios have the same conditions as the last two. And on the left, we start with an initial velocity in the x direction. So it's going to basically want to go to the left, but it's going to have a similar movement. So it's going to curve up and curve back down again, but it's going to do a weird loop-de-loop thing as it goes along. And those loops will just keep continuing on and on. And on the right, it's the same thing again, but it's with an initial velocity that's larger in the x direction than the other one. So it's going to have tighter loops in them, but it'll also just keep doing the same thing where it's just gonna loop and then loop and loop again. And that's just about it.